All right, so for this, um, we are gonna find extrema on closed intervals. So what I mean by extrema? Extrema is the highest point or the lowest point. So anybody else missing? No. Okay, so we're gonna find extrema. How do I find the extrema? Find extrema between on a closed interval. How do I find the extrema on a closed interval? On AP exam, they love this type of questions, especially FRQ. Those of you guys take FRQ last year, they always says, find the maximum speed or maximum, that says, I don't know. Find the particle is to the furthest right or furthest left. Okay, so you have to take a derivative, find the velocity, and then you had to find a critical value, and you had to find the endpoints. Because if you don't compare the endpoints, it's not, because sometimes your answer is at endpoints. Do you guys remember that last year? That you always have to do that. So we want to talk about how do we find the extrema on closed intervals. So that's a very, very important skills for you to have. They might apply on a word problem, and it might it might apply on the word problem. It might apply on MCQ. So those are things I think is a very, very foundational knowledge that students have to get. So those are the things I will pay attention to. So how do I find the extrema on closed interval? So if you have a closed interval between A and B, what do you think? The option need to be there? Yes.
Take a derivative.
Why do you take a derivative?
Because you want to find the critical values.
Right. Okay. What else?
Like the next step.
Mm-hmm.
Once you find the critical values, you plug them in, and the highest one would be the maximum, and the lowest one would be the minimum.
Okay, but there was something that's missing.
Check endpoints.
Right. What happened? What if the endpoint's higher or lower? You don't know, because extrema here is the absolute maximum and absolute minimum, right? So you might have to check the endpoints. So first, you want to do is find critical value, right? Find critical number. And we just say number like this in between A and B, right? Second, we want to evaluate the critical number. Means you find the output. You will compare the output. Now, at critical point, it doesn't mean only derivative equal to 0. What else? Derivative is equal to what? Undefined. So the critical number means two things, right? That means dy dx is equal to 0 or dy dx equal to undefined. And we're going to talk about that's important as well. And then evaluate the critical number. So the critical number could be in two situations. In the third situation, you have to evaluate the endpoint. Evaluate the endpoints. So endpoints is very, very crucial because you don't know what endpoints higher or lower. And then 4 is compare all of them, right? Compare all the output, right? All the outputs. I think that's a probably best way to think about it. You can find out the greatest minimum or the absolute maximum. So find absolute maximum and absolute minimum, which is that's called an extrema. Okay, absolute maximum, absolute minimum, that's going to be extrema. So let's try one and let's see if you guys can find it. We'll kind of give you the guideline already. We're going to give you 3x to the fourth minus 4x to the third, and the between -1 to 2. Okay, I'll let you guys get a head start. And you're going to tell me where is it. I already kind of give you the steps.
What's 3 say?
Evaluate the endpoints. Endpoints with a S. Sorry, my handwriting gets very sketchy when I drink too much coffee.
Compare all these
Outputs.
outputs. Okay. Wow.
It's okay. Your handwriting's not better than mine, so you cannot judge. So we said between -1 to 2. Robert, you already done? Do you know how to start?
Today.
What?
He's done with today as a whole, not just the problem.
Why is still a class the joke in this one?
I'm okay, it's fine.
I kind of want to hear the joke. Nicole is like, no, you don't. I heard that on TikTok there was a slap a t-shirt on challenge, right?
Is there?
Oh, I think there are.
We did it.
Huh? I'll break your arm.
Seems like a fair trade-off to me.
This is self-defense, so.
How many arms are you willing to break?
You guys finished? So this one's pretty easy, right? So on AP exam, they usually want you to do it in terms of tables. So that will help you. So for me, that I just take a derivative, right? And I'm going to get 12x to the cube minus 12x squared. And then I can take out 12x what? Square. So that's going to give you x minus 1, right? So x equal to 0, x equal to 1. So on AP exam, they usually want to say, hey, do x, y. You're going to plug in the -1. You're going to plug in 1. And you're going to plug in, 0, 1, and 2. And if you plug in -1, what am I going to get?
7.
I think 7. Okay. If I plug in 0, I'm going to get 0. -1, good. And if I plug in 2? 16. So where's my absolute, where's the absolute maximum at?
And 2.
So remember how AP exam is going to ask you a question is the way it asks you. They say where does the absolute maximum occur, then you're going to say x equal to 2. If they ask you absolute maximum value, if they ask you value, that means what?
The Y value.
The y value. So absolute max, right? If I say where, right? Where, then you're gonna say x equal to 2. If you say absolute max value, and the way I kind of think about value is yu, is y value. Does that make sense? So you think about you draw a line and become yu. So therefore, it's gonna be 16. So it happened at the endpoint. It happened at endpoints. How about at 1? This is absolute minimum value, right? And minimum value is going to be -1, occur at x equal to 1. So remember how you write it. You're going to say how occur at x equal to 1, but if you want a minimum value, then it's going to be -1. Are we okay here? Okay. Now be careful on the second question. So the question I'm going to ask you is on the second one here. The second one is actually a little bit more tricky, okay? So I'm going to say 2x minus 3x to the 2/3. There's more tricky to this, so you got to be cautious. Be cautious. Be cautious.
Is that to the 2/3?
Yeah, it's to the 2/3.
What's the interval?
It's true. That's a good question. Between the interval between -1 to 3, right? Now there was something weird happened here. You gotta be cautious. Be cautious. I'm gonna tell you be cautious. Why you had to be cautious? Because
Negative exponents?
no. By the way, do you guys know what happened when you have even over odd power? It's a cusp, yeah. It's a cusp warning. So you will have a cusp. Yeah. Can she go at end of the period? Okay. Wait. Which room is it? 11:101. Okay. Julia, at end of the period, you're gonna go 11:101. Just pick up some paper. I have no idea what it is. So how many critical number you find?
1.
No. There's 2. Critical number, there's a 2. Endpoint, there's a 2. So there's 4 points that you had to see. So there's 2 critical number. That's what I'm going to show you what happened here, right? So if I take a derivative, what am I going to get? 2 minus 3 times 2/3 times x to the -1/3. Does that make sense? So 3 cancel out. 2 minus 2x to the -1/3. Now be careful with this, because this one that you had to be cautious, because if you have f prime of x is equal to 2 minus 2 over x to the 1/3. Now you need to combine fractions. So you need to multiply this side by x to the 1/3 and x to the 1/3. So therefore is equal to x to the 1/3, and this one's going to be 2x to the 1/3 minus 2. Now guess what? It's equal to 0 and also equal to undefined. So when does it undefine?
0.
Yep. X to the 1/3 equal to 0 is called a vertical tangent, right? At that 0 usually has a vertical tangent, because when denominator of a derivative is equal to 0, there is a vertical tangent. So x equal to 0, or 2x to the 1/3 minus 2 equal to 0, 2x to the 1/3 equal to 2, x to the 1/3 equal to 1, x equal to 1, not -1, because the 1/3 is not 2/3. So therefore x is equal to 1. So there is a horizontal tangent there, and there's a vertical tangent when the dy dx denominator equal to 0. But not all denominator equal to 0, because sometimes original function has a denominator equal to 0. So original function in denominator equal to 0 is actually vertical asymptote as opposed to vertical tangent. This case is a derivative, the denominator equal to 0. Sometimes they are the same. Then vertical asymptote win out. Okay? They win that situations. Does that make sense? Yes? Good? No problem? Then I have to plug in all the values. How many values I'm going to plug in? -1, 0, 1, and 3. If I plug in -1, what am I going to get? Is what? No, it's not 2. Something to the 2/3 power make it positive. -5. If you plug in 0, easy, cake. Plug in 1, what am I going to get? Not 5. -1. And if you plug in 3, that one's kind of weird. What's a 6 minus a weird number, right? 6 minus, I think, 3 to the 3rd root of 9. That's roughly about -0.24. If you're using calculator, figure that out. So if I were to graph at this, if I were to graph this at -1, I'm going to get -5. It's going to be a -5, right? And at here, it's going to go to here. At here, at 1, it's going to be -1. And I hear about 0.24, so it's right here. So the graphs actually end up to be like this. It's a cusp. And here. So this is absolute min. And there is an absolute max at where? Yep. So if a minimum value is going to be -5, maximum value is going to be 0. Where did that occur? Occur at x equal to -1 and x equal to 0. Am I causing any confusion? No, it's okay. So the tricky part is here. Oop, my bad. The tricky part is that you have to combine fraction. Because if you have something like this, very risky is you don't know denominator equal to 0 also count as a critical number. That's one of the things that people usually test you on, is to test you if the critical number is derivative can be undefined, because those can be a relative maximum, minimum as well. This case is not only relative maximum, it's actually absolute max. So those are things that you should pay attention to. I always tell students kind of be cautious of those. And is that okay? Okay. So yes, we're gonna talk about the next part. How about, can it be a trig functions? Yeah, they can be trig functions. You thought like you never get done with trig. Since you guys are BC, you guys have to learn how to deal with trig. How to know all the values. Even though you failed that trig test, you had to go back look up how to do a value. So in this case, we won't want to be between 0 to 2 pi. Right? We want to be between 0 to 2 pi. Derivative of this is a good practice. Now, refresh yesterday, right? Critical value, not in this case, but critical number can be a maximum, minimum, but doesn't have to be maximum, minimum. They can be, but it doesn't have to be. Sometimes they have a stationary points. They just kind of go there and pause and move on. So sometimes it can happen. I don't think in this case happen, but in other cases it might. How many critical number you get between 0 to 2 pi? You have to know your math. You have more than 2. Connor, how many you got?
I don't remember double angle identities.
You don't? Do you need double angle identity? Oh, well, yeah, you do. You do need double angle identity. Yeah, so all those identity helps. And that's one of the test questions we gave earlier. Those of you guys don't know your double angle identity, you need it for sine and cosine. Cosine has 3 different forms. In this case, you have to know the sine.
Is it pi over 3?
Pi over 3 is one of them? No, pi over 3 is not one of them.
Yeah, well, never mind.
The critical number is going to occur at where? Pi over 2, 7 pi over 6, 11 pi over 6, 3 pi over 2. It should be 4.
Wait, would it be 5 pi over 6?
No.
Oh, should be 7, right?
So there are 4 numbers here. Mandy, do you know your double angle identity?
Yeah. It's sine 2 sine x cosine.
Yep, sine of 2x is equal to 2 sine of x cosine of x.
You don't have sine of 2x, you have cosine of 2x. When you take the derivative, you get the
You haven't taken derivative yet. The original function doesn't need to worry about it. Right? Can I take a derivative of this?
Yeah.
Be 2 cosine of x. What's the derivative of cosine of 2x?
2 sine 2x.
plus 2 sine 2x.
2 sine of 2x.
Alright.
Because there was a layer here, and there was a layer inside. So it'd be cosine is going to be negative sine of 2x times derivative of inside, which is 2. Yes. So those are the small things that you guys have to be very cautious. Okay, so there was a chain rule. Okay, so now you're gonna be like, I don't know how to factor this. Well, the thing is, you have two different type of trig functions, and not only two different type of trig function, you have the angle inside are completely different. So there is nothing I can do. So except what you can do is you can change this. You can change this to, oh, sorry, this I just missed a 2, right? 2 cosine of x and then plus 2. Now, that's going to be 2 sine of x cosine of x. So that's equal to 2 cosine of x plus 4 sine of x cosine of x. Because that's a double angle identity. Make sure you know this. It will show up. And make sure you know the other one too. It could be cosine square of x minus sine square of x. And that's the one I remember. I can derive the other two. I'll substitute the sine square equal to 1 minus cosine square. So that'll be 2 cosine square of x minus 1 or equal to 1 minus 2 sine square of x. So those are things that's kind of important in the past that is going to come back to help you or hurt you.
Is it 11 pi over 6?
11 pi over 6, 7 pi over 6, 3 pi over 2, and pi over 2. So I'm going to equal to 0. I'm going to take out 2 cosine of x, I think. That's going to give you 1 minus 2 sine of x, positive, sorry, is equal to 0. Cosine of x equal to 0. And the sine of x equal to negative 1/2. X equal to pi over 2. X equal to 3 pi over 2. X equal to what? 7 pi over 6. And what? 11 pi over 6.
Sine of x equals.
This is negative 1/2.
Oh, okay.
My fault.
Trying to trick me up here.
Thank you for catch my mistake. Yeah, pre-calc does come back to bite you in the butt sometimes. So then you should plug in all those values. Again, you have a lot of value here. So you got x and y. I'll plug in 0 to 2 pi. And of course, I'll plug in all this value, and I'll just wait for you to evaluation. I'm not going to evaluate all those stuff. So I'll go by order though. Pi over 2. 7 pi over 6. 3 pi over 2. And 11 pi over 6. And you should be able to get a lot of different values here. I'm just going to give it to you because I'm lazy. Negative 1, 3, negative 3 over 2, and negative 1, and negative 3 over 2, and negative 1. So absolute max occur at 3. And min is happening at here. This is absolute max and min. Actually, in this case, could be relative as well. Yeah, those are two absolute min. You can have more than 2 because they both are at the same value. So you can have more than 1. So this case is absolute. At 3 pi over 2, that's a relative max. So this is an absolute. So absolute, absolute, absolute. This is relative max. Am I going too fast? Nope. That means we keep on going. What's the first derivative tell you?
The slope of the function at that point.
The slope of function is what?
The slope of the function at any point.
At any point. But if f prime of x is greater than 0, what does that mean?
It means the function is increasing at that point.
Right. So we're going to talk about the next sections because we don't have time to waste. Tests for increasing and decreasing. And you guys should know this. Increasing versus decreasing. So if f prime of x is greater than 0, that means f of x is what? Increasing. F prime of x is less than 0, f of x is decreasing. F prime of x is equal to 0, that means f of x is constant. Yes, second derivative is going to be concavity, but the first derivative is increasing and decreasing. Do you guys know that what is a first derivative test?
What do you mean?
Do you guys, because a lot of people get confusing with increasing and decreasing and first derivative tests. What is a first derivative test? Okay. So, yes, Nicole?
When it goes, so if the first derivative goes from positive to negative, then you know that there's a critical number there.
No. From positive to negative, you are going so well, and then not just critical number there. It's true, but it went from positive to negative means what?
A minimum or a maximum.
Well, which one would it be? Maximum. So the first derivative test tells you, and the second derivative test. Do you guys know what's the difference between first derivative test and second derivative test?
You just take the derivative of the derivative?
Yeah, but that's the second derivative, but doesn't mean test. They all have a common goal. What's a first derivative test and second derivative test? They all have a common goal. They just express differently. First derivative test and second derivative test, they have a common goal. Those of you guys never learned it, it's okay. Their common goal is looking for maximum and minimum. It just look at it differently. So don't get confused. The test for increasing versus decreasing, that's not first derivative test. The test for increasing, decreasing basically tell you f prime of x is less than 0, the function is decreasing. The f prime of x is greater than 0, the function is increasing. But that's different than first derivative test. First derivative test says, just like what she said, she says f prime of x changing from negative to positive, then f has relative minimum. And f prime of x changing from positive to negative as c, they have relative maximum. So if f prime of x change from positive to negative. So let's talk about first derivative test. Sorry, let me title that. That's like super important on AP exam. First derivative test. Kind of makes sense. If you increasing means positive, decreasing means going down, so you have a relative max. Does that make sense? If you go up and come back down, therefore relative max. Okay, so f prime of x changing from positive to negative. Add the c value, add c. Then you will have as c comma f of a c is going to be a relative max, and vice versa, f prime of x change from negative to positive at c. You will have c and f of comma c is relative min.
Don't you use a number line test for this?
Yes, we're going to talk about number line tests. Good job. And we're going to talk about a lot of different number line tests. Okay, let's talk about the first one. Let's go back to the first example. Let's go back to this one. Now, this one I'm not going to give you an interval anymore, so it'll be 3x4. I don't like that one. I don't like that one either. Let me pick one I like. Okay, let me pick this one. So let's just say f of x is equal to x cubed minus 6x squared plus 15. I don't know if this one's a good one. Hopefully, let's pray. Pray this is a good one. Okay. So in this case, what if I just want to find out where the maximum and minimum is? And we don't give you an interval now. So if you don't have interval, you don't have to worry about endpoints. You just have to worry about critical number. Does that make sense? So can I take a derivative to this?
Yeah.
And that's equal to 3x squared minus 6x. Can't multiply. So sad. What an idiot. 0 equal to 3x squared minus 12x. And that take out 3x, that's going to be x minus 4, 0. Are we okay here? X is equal to 0, x is equal to 4, right? So I will do a number line test. I do it this way. Mr. Cray did a different way. Mr. Cooper did a different way. So whatever did works for you, then works for you. I don't want to change it, but this is the way I do it. So I'm going to say 3x and x minus 4 here. And then plug in a number between negative infinity to 0 and 0 to 4 and 4 to infinity. So let's plug in that. Let's plug in negative infinity. And if I plug in negative value, I'm going to get a negative value. Negative infinity minus 4 is going to give you a negative. So therefore, the sum of the sign is positive. If I plug in 1 into 3x, I'm going to get positive. If I plug in 1 minus 4 is negative. So it's negative. Does that make sense? If I plug in 5 times 3 is positive. 5 minus 4 is positive. It's positive. So therefore, I write on the bottom. I says increasing, decreasing, increasing. That's the way I did it. Okay, and it's very systemized. And I hear that's going to give you a relative what? If it's increasing and decreasing, that's what? Max. At x equal to 0, right? And there's a relative min at x equal to 4. You can go back to find out what the y value is and what the x value is. Now, what people usually do is they thought they find a critical number that's automatically their maximum minimum. That's not true. A lot of time, you find a critical number, you can have a pause. You can have a stationary point. So you have to do the first derivative test. If you don't do the first derivative test, most likely on AP exam, they trick you. So if you don't do it, then that means they will trick you. Because all those critical number doesn't mean they are maximum min until you go in to prove it with the number lines. Now, number line does not give you a point on AP FRQ. No point for number line. But you have to say x equal to 0 is going to be relative maximum because the first derivative test. Because f prime of x changing from positive to negative, therefore you have a relative maximum. They usually give you justification points. The number line does not represent a justification point. It's just to help you, guide you to get the right answer. Am I going too fast? No? Yes?
So you just plug in, like, once you factor the derivative, you plug in the numbers to each, I guess you
Yeah.
can split it
For
up.
example, if I plug in, I hear negative infinity to 0, I plug in negative 1.
Okay.
And negative 1 plug in to 3, it's going to give you a negative sign. Negative 1 minus 4 is a negative sign. 2 negative signs is equal to positive sign. Okay. I do it more system lines because sometimes you get derivative, they automatically give you a derivative, right? Sometimes they give you like, they even says f prime of x. Sometimes the way they trick you, I think is this way. They will say it's 3x, negative 3x times x minus 2 squared. It's the derivative. They say, hey, can you find a relative max and min? But they don't even ask you to take derivative. They already give you a derivative. Like sometimes they do that. What do? You plug in, right? And you plug in that just say if you have it's at 0 and 2, right? And now plug in negative 3x and x minus 2. Be careful with this because everything square is going to be always positive. Does that make sense? It didn't matter what sign is. Even though there's two critical value, right? Now, if you plug in negative here, if I plug in negative, actually negative negatives, it actually becomes positive. Does that make sense? And this will actually end up in negative. So there's a positive, negative, negative. So at 2, it's not a minimum or maximum. At 0, it's a relative max. At x equal to 0. So sometimes they trick you that way because you don't do the number line test. Every question, please do the number line test.
Could you show us that on Desmond?
Yeah, of course. Negative 3x times x minus 2. That's good question. Negative 3x times x minus 2.
I think it's squared.
And square, right? So let's look it back. X equal to 2. X equal to 0 is, wait, did I type in right?
Yeah, but that's a derivative, so it's saying x.
Oh yeah, that's a derivative. You're right. So that will, I don't know what the original function to be though. So we gotta figure out what the original function is. So the decimal doesn't work. Sorry about that. Thank you. Can somebody answer that?
Good, how are you? Is Alex Novell in class?
Yeah.
Yes, he is. Can you go to guidance for your belongings, please? Alright, cool. Guess how I was doing? Mr. Yazer? Julia as well? Julia in class? Oh. Go to guidance for your belongings. Go to 11-101. Okay, bye. Okay, so 11-101, but you go to guidance.
Okay.
Yeah, you go to 11-101.
She just said, can you send her as well? So I thought that's what it meant. Go to guidance as well.
Thank you.
And then she yelled at me.
She yelled at you?
She was like, no, 11-101.
No, she didn't yell at you. That's her way of saying she wanna change that modifier change. How much time I have?
3 minutes. Just give us a break.
Okay, fine. We cover first derivative test, that's what I want to cover, and we can cover next week's concavity and second derivative test, which is fine. Margot, do you get it? Margot's online. Margot, put a click, like, and subscribe. Is that what you say? Like there's 2 viewer. There's 2 viewer. Huh? Do you guys see my shirt? Do you guys see my shirt yet?
Yeah.
Funny.
You guys see my
I
shirt?
like angles to a degree. Just give me a sign. Give me the sun when you got sign and cook.
But you guys see the back of the shirt.
That's the back of it.
This is my funeral picture. Can you imagine you come to my funeral, I have this picture posted.
How did you make? What did you make this shirt and why?
My student made it for me.
Do you have an extra copy of that?
No, right? This is my either my death picture or my album picture for my
Yes.
the tape. What do you guys call it? Mixtape? My mixtape. It will be my cover of the
That'd be a
album.
great album cover. No,
Yeah, you'll buy that just for the album, right?
give me an album with that, I would listen to it.
Me start rapping.
You should write a math
Or
rap.
your Twitch.
Honestly, that'd be great.
Huh?
You should write like a math rap.
Yeah, that would be cool.
Rap like a whole. Like,
I don't know how to rhyme though.
a whole